So finally here what we have derived is current gain, is it? This is, let me write it, is current gain with respect to voltage source, is it? So this is first parameter that we have derived. Now let us move towards the second parameter, is it? And as I told you, the second parameter that we are going to consider is an impedance, is it? So let me write it here. It is a second parameter, that is impedance. Impedance of the module. And what the impedance is denoted by? Impedance is denoted by Ri. In some books you will find R in, R dash, or maybe simply Ri, is it? So we are using Ri is the notation for input impedance. So what will be the input impedance of that hybrid module of a transistor? That's what we are going to find, is it? So those parameters, that is input impedance, output impedance, current gain, voltage gain, those are actually the basic important parameters of an amplifier, is it? Now what we are doing, we are calculating those parameters for transistorized hybrid module, is it? Because we know that if I understood the transistorized hybrid module, then by inserting 2 or 3 capacitors and resistors, that is biasing resistors and some coupling capacitors, it can become an amplifier. See, the transistor module can become an amplifier by inserting 2 or 3 extra resistors and capacitors. So that's why first we are trying to understand what is the value or equations of those parameters which are actually related to the amplifier, right? So let us start with input impedance. The notation that we are using is Ri. Now for any circuit, for any electronic circuit, what is that impedance stands for, or what I can say resistance stands for? If it is input impedance that I am talking about, then it must be input voltage divided by input current, that is V1 divided by I1. V1 is the input voltage and I1 is the input current. So input voltage divided by input current will obviously represent the input impedance, right? Now from the input part, from the input part of which circuit? Let me show you. From the input part of this circuit, let me copy and paste the same circuit again. Okay, this is not actual one, it is messed up. Okay, let me take that one. Let me copy and paste the same circuitry, because the circuit is useful in all the parameters. So here we're supposed to paste it. Now consider the input part. We are interested in this, we are calculating input impedance. So at the input side, just observe the input side and just check what I am writing. I am writing V1 is equals to, see, I am writing V1 is equals to, that is input voltage, this voltage I am writing is equals to Hi multiplied by I1, that is I am talking about this voltage. Now let me write down Hi multiplied by I1. Okay, let me rub this as it's a small mistake. Okay, Hi multiply by I1 plus HR V2. Let me adjust that somewhere here. Now see whether I can write properly. Not yet. Now see. Yes, now it's quite okay. Now I1 plus HR V2. Now what is this voltage? This input voltage is nothing but voltage across. Let me check the pointer. This voltage plus this voltage is nothing but input voltage V1. So I am writing V1 is equals to Hi multiplied by I1, that is this, multiply by, sorry, plus HR V2. So that is what HR V2, is it not? So this is what value of V1, right? But see, what is my intention? I want to find out value of Ri, that is input impedance. So if I am interested in input impedance, then I must write V1 divided by I1. Now in this equation, I will put value of V1, that is Hi multiplied by I1 plus HR multiplied by V2 divided by value of I1. Right. Now let me simplify this. Let me split this. Now if I split this, then what I'm getting? I'm getting HI1 divided by I1. So I1 will get cancelled, and finally I am left with HI. Yes, is it not? So it is HR V2 divided by I1. That's what it is. So it means what I'm getting for Ri, input impedance, it is equals to HI, input impedance is equals to HI plus HR V2 divided by value of I1. Right. Now what is that V2? V2 is output voltage, is it not? V2 is output voltage, where let me write, where V2 is output voltage. V2 is a output voltage. So let's find V2. Now I'm interested in V2, because if I get V2, then obviously I can write the equation of Ri in the form of resistance as well as current. Because V2 is output voltage, output voltage is a form of output current and output impedance. So that's why I am interested in finding V2. Is it? So now V2 is equals to what? V2 is equals to minus of I2 multiplied by value of load resistor RL. Now from where I am getting this? V2 is equals to minus I2 multiply by RL. You remember the first equation that we have written, where it is in the first derivation, that is current gain. Look at this. Now we are using this equation, V2 is equals to minus I2 multiplied by RL. Why I am writing minus I2? Because V2 is output voltage, whereas output voltage is equals to output current multiplied by output resistance. So that output current IL is nothing but minus I2, because they are in same in magnitude but opposite in phase. So clearly I am writing V2 is equals to minus I2 multiplied by RL. Now come back to our case. Here we are. V2 is equals to minus I2 RL. Now I want value of I2. How I will find a value of I2? Because I want to simplify V2. Is it? So if I want to simplify V2, I will get the value of I2. Is it? So value of I2, is it? Value of I2 is equals to minus AI. You remember that it is minus AI multiplied by I1. Minus AI multiplied by I1. How? Now if you don't know this, let me write AI. We have this equation, AI is equals to what? It is minus I2 divided by I1. So if AI is equals to minus I2 divided by I1, then value of I2 is equals to clearly AI multiplied by I1. Is it not? Yes, or clearly I can say minus I2 is equals to AI I1. So if I put it here, then value of V2, right? So value of V2 will become then AI I1 RL. So I will write AI I1 multiplied by RL. That's what the value of V2 I am getting. Now why I got this V2, why I tried for this V2? Because I want to put this value of V2 here in this equation. That's what I'm hunting for. Is it? So let's put value of V2 in equation of Ri. Then value of Ri, that is equation of Ri, will become Hi plus, now HR V2, HR multiplied by this value of V2. So it will be HR multiplied by AI multiplied by I1 multiplied by RL divided by, now what is that? I1. So can I cancel I1 and I1? So finally Ri is equals to what? Hi plus HR AI multiply by RL, and this is what the value of input impedance of hybrid module of a transistor. This is input impedance. Is it? Actually, we can extend the input impedance equation. Yes, we can. It is possible, but we are not going to do that because that much is sufficient, I think. Is it? That much, which is in the form, that is Ri is in the form of Hi, HR, AI and RL, and that is okay for me. Is it? So that's why we will conclude this equation of Ri. That is what second parameter that we have derived. Now till now, two parameters we have derived. The first parameter is input, no, the first parameter is related to current gain. Yes, it is current gain. Sorry, I forgot. So first parameter is current gain, that is AI. Then second parameter we have derived just now, it is Ri, that is input impedance. Now let us turn towards the voltage gain, which is the most important if we are a designer of amplifiers. Is that so? Here let us start with third parameter. What is that third parameter? Third parameter is, so I'm not comfortable in writing here. The third parameter is gain. What is gain? Actually, it's a voltage gain. Okay, the notation that I'm using is AV. Is that? Now, as like current gain without voltage source consideration, here also we will find out the voltage gain without consideration of voltage source Vs, and again we will consider voltage source Vs, and then we'll find out what is voltage gain. Is it? So again here, like current gain, we can have two parts. That is, one part is without considering Vs, and the second part is with considering Vs. That's what is Vs? Vs means voltage source, that is function generator, the voltage that I have applied with the help of function generator to the H module of a transistor. That's what I'm talking about. Is it? So let us start with what is voltage gain. I'm interested in AV. Voltage gain is what? Output voltage divided by input voltage. So let me write here. Let me write here. It is voltage, that is output voltage divided by input voltage. If it is current gain, output current divided by input current. If it is power gain, output power divided by input power. If it is a voltage gain, output voltage divided by input voltage. So I'm writing V2 divided by V1. But see, value of V2 already we have derived. Where it is? Just check value of V2. Do we have value of V2? Value of V2 is there with us. Look at this. In the previous parameter, that is Ri, input impedance, while deriving equations for input impedance, we have derived V2 is equals to AI I1 RL. So I am using that. V2 is equals to AI I1 and RL. That's what we do. Now put this value of V2 in this equation here. Then I will get AV is equals to AI I1 RL divided by V1. But now observe the equation carefully. What I'm getting? I'm getting the ratio of current and voltage. If the ratio is of voltage to the current, that is V divided by I, then I can say it is an impedance. But what is this? Inverse of impedance. Is it? Okay. Let's not enter into the inverse of impedance or something. Clearly, what I can say is, observe this term, I1 divided by V1, input current divided by input voltage. So can I replace this? Can I replace this with 1 divided by input impedance? Yes, it is possible. No matter what is the equation of Ri, the matter is it is a ratio of input current to the input voltage. So 1 divided by Ri is purely valid. So let me write it here as AI RL divided by Ri, and that is what my voltage gain. See, isn't it so simple? See, things are so simple that I have derived AV is equals to AIRL divided by RI. But what is that? It is a voltage gain. Look at this. It is a voltage gain without considering Vs. In this complete process, we have not considered the source voltage at all. Is it? We have not considered source voltage. So if I am not considering source voltage, then it is a gain without considering source voltage. Now let us observe what will happen if I consider Vs. Is it? That is source voltage. Let me write here. Now let's consider Vs, that is source voltage. Is it? I will write here source voltage. Now if I consider source voltage, then obviously this character, that is Rs, will come in picture. Is it? Rs definitely will come in picture. Is it? Why it is coming in picture? Because Rs is the source resistance. Is it? The resistance or impedance offered by the source. Is it? So what we do? We generally draw a source and we draw a series resistance Rs. This is how generally people show the source impedance. Is it? So that's why I'm considering source means I have to consider the source impedance Rs. Is it? So what is that Rs? Rs is a, let me write it here, it is a source impedance. It is a source impedance. So that's why it must be there. Now if I want to find out what is the voltage gain, if I consider source voltage, then the notation that I am using is AVS. It is an obvious AV and AVS. Now AVS, that is output voltage divided by input voltage. Now what is the input for me now? Input for us is now source voltage. So the equation will become V2 divided by Vs. Is it? Now follow the same process. If I write V2 divided by V1 multiplied by V1 divided by Vs. Yes, it is valid. Simple mathematics. V1 will get cancelled. V2 divided by Vs will remain as AVS. Is it not? So now simplify this again. AVS. What is this? V2 divided by V1. It shows gain, that is voltage gain without Vs. So it means I have to write it is AV multiplied by V1 divided by Vs. Call it as equation number 1. Is that? For simplicity, call it as equation number 1. So I finally got AVS in terms of AV. But this is not the end. I want AVS in the form of impedances. Is it? I want AVS in the form of impedances, because see, this is AVS in the form of AV. What will happen if I don't know AV also? Is it? If I want to find AVS and I am not aware with AV, then obviously this equation will be useless then. Right? So let us then find out AVS in the form of impedances. Now AVS in the form of impedances. How can I go for it? Let me draw the circuit diagram first. So this is actually a source voltage that I have connected. This is as defined source resistance. This is a current flowing through it, that is I1. Let me write it as Rs, and this is a source voltage I have connected, it is Vs, and somewhere here it is, if I am looking by this way, it is input impedance Ri. Yes, that's what. Now this is what input side. What is this? It is a input side. Now if this is the input side, then apply voltage division rule to find out what is input voltage. Input voltage means what? Input voltage means this voltage I am talking about. This is actually input voltage, is it not? Now I am interested in input voltage. Now, is it? So let me write down to find out input voltage. Is it? What I will use? What do you call this as potential divider rule or voltage division rule? Okay, it's a voltage division rule. Apply voltage division rule. I will write here apply voltage division rule. Now, what will happen if I apply voltage division rule? Look at this: two resistors, one voltage source. The current is flowing through it. Then the by voltage division rule, VI, that is input voltage, is equals to what? Actually voltage Ri divided by the resistance across which I want to find the voltage, that is what Ri, divided by sum of the two resistors, that is Ri, plus multiply by the source voltage Vs. Is that? So it means I can write Vi divided by Vs is equals to Ri divided by Ri plus Rs. So what I am doing, I am concluding with a ratio of input voltage to the source voltage. Is it? Why I am doing this? Because I want to put this value here. Now you will get why I am hunting for the actual thing. Look at this: V1 divided by Vs, and this is Vi divided by Vs. Now what is that Vi? Vi is nothing but your V1. Is it? You can call this as Vi, no problem at all, because Vi is nothing but your input voltage. V1 represented the input voltage in the previous case. So that's why now what I will do, I will put this value here in this equation. So let me write put value of V1 divided by Vs in equation. Do we have written equation number? Okay, equation number, we have written equation number 1. Then now the equation number 1 is related to what? The equation number 1 is related to AVS. Then equation number 1 becomes AVS is equals to AV multiplied by Ri divided by Ri plus Rs. Is it not? That's what. AVS in the form of AV. Is it? But still I am not satisfied. I don't want AVS in the form of AV. Then what I will do, if we put value of AV, then what value of AV? AV is equals to AIRL divided by Ri. Is it not? AIRL divided by Ri. AV here AIRL divided by Ri. AIRL divided by Ri. Now look at this. Now put this value of AV in the equation of AVS. Then AVS will become now, look at this, it is AIRL divided by Ri multiply by Ri divided by Ri plus Rs. That's what it is. Now this Ri and Ri will get cancelled, and finally what I am getting? I am getting AI, what happened? RL divided by Ri plus Rs. This is what a voltage gain when I connect source voltage. This is what the final conclusion. Let me have it as a dark block. This is what my dark block is. We have concluded with a voltage gain with source, that is a voltage gain when I consider or when I apply input source, input voltage by function generator. That's what is it. Now see, we have finished three parameters. One is current gain, and in the current gain itself, we have studied current gain without consideration of input source and with consideration of input source. Then we have finished with input impedance. Then we started with voltage gain, that is voltage gain without consideration of Vs and voltage gain with consideration of Vs. Is it? Then we supposed to start with the last parameter, that is what is remaining? Oh, output impedance. Output impedance. Let me start with the next parameter, output impedance. The fourth one is output impedance. Generally people don't calculate output impedance. What they write for hybrid module, they write for output admittance instead. Is it? Why? Because we have 1 divided by HO. Is it? In the equivalent module, if you have observed, what we have 1 divided by HO. And what is that HO? HO is nothing but output admittance. So if I get the value of output admittance, then obviously inverse of it I will get output impedance. Is it? So generally for an amplifier people write output impedance. If they are analyzing hybrid module, they used to write output admittance. Is it? So no matter, if you find admittance, it will be easy for you to find out impedance. If you find impedance, then it will be easy for you to find admittance. So no matter what you are deriving, which one is easier, will go with this. Whichever is easier, we'll follow that. So let us start, or let us think about which one is easier, whether it is easy to find out impedance or admittance. So already we know that related to H module, we have derived so many equations. So obviously it is easy for us to find out admittance instead of impedance. Is it? So let us write impedance, output impedance and output admittance. What is the notation that I am using? I am using YO. Admittance I am talking about, is it? So now let me round off this, because I am not going to find this impedance, because I am going to find out output admittance, YO. So what is that admittance generally? General equation of admittance. Admittance is current divided by voltage, is it? So if it is output, then I need to write output current divided by output voltage. Yes. And one important thing, if you are finding out output impedance or output admittance, then output admittance, or what I can say in the simple language, that you can find output impedance only when you short circuit input part. Now this is okay. See, to find out output impedance or to find out output admittance, you have to first make sure that input voltage or input source is short circuited. Is it? जब तक आप इनपुट शॉर्ट नहीं करते तब तक आउटपुट का पार्ट कैलकुलेट ही नहीं कर सकते. You might have studied this in network analysis, is it? The whole network analysis is, I think, based on that concept that if you want to deal with output parameters, input has to be shorted. Is it? So input short करना ही पड़ता है अगर output का कुछ find out करना है. So obviously then output admittance, that is YO, is equals to I2 divided by V2 when Vs is equals to 0. Vs means what? Source voltage. So obviously source must be 0. Is it? Now you you remember the equation. Is it? You remember the equation that we have written while calculating gain, that is current gain, which is the equation current. Okay, it takes some time to load. Where it is? I2 is equals to this equation. You remember that equation? Yes, let me copy this equation because I am going to use this equation. Yes, what is this equation? It is equation of I2. So I2 is equals to what? Okay, I have copied it. I2 is equals to HF I1 plus V2HO. Now let us use that equation here. Right? Why to derive the equation again and again? Whatever we have derived, I am using it. Is it? So let me paste this equation somewhere. It is, yes, it is pasted. Now this is what, this is equation for output current I2. Now the thing is clear. I2 is equals to what? I2 is equals to HF I1 plus V2HO. Now in this equation, HO term is there. Already we have derived I2 is equals to HF I1 plus H2 V2HO. So HO is there. Now from this equation I will find HO. That is output admittance. Is it? HO is what? HO is admittance. For my case, admittance of an hybrid module. I am interested in transistorized hybrid module. So I am writing YO instead of HO. So I want YO in the form of HO. That's what my aim is. I want YO in the form of HO. Actually, you can go and analyze further and further, and you can get YO in the form of HF, HR and HI also. Is it? It's not only getting YO related to or YO in the form of HO. You can get YO in the form of HR, HI and HO. It is possible if we extend our analysis further. But for the time being, we'll restrict somewhere. Is it? कहीं तो रुकेंगे हम, ज़्यादा analysis नहीं करेंगे. Is it? So somewhere will stop when I get a value of HO, which is useful and which is where I can satisfy, where you people, both of us will satisfy. So let us write equation I2. Now V2 term, that V2 term is somewhat bothering me. Look at this V2. It is bothering. I don't want this V2. So what I will do, I will delete that V2 term. It means I have to divide by V2. Is it? So divide your left hand side by V2 and right hand side with V2. HF I1 divided by V2 plus V2 divided by V2. Now see what I am getting, H2, output current divided by output voltage. Am I talking about this then? Seriously, look at this. Am I talking about this? Yes, that's what I am talking about. Look at this. It means I am getting YO. Yes. Now this V2, I can cancel them. Yes, can I cancel them? So I will write YO is equals to, this is what YO. So YO is equals to, now it is HF divided by V2 plus HO, and that much is sufficient actually. What I feel is equation of YO in the form of HF and HO is sufficient. Is it? If you want further analysis, it means if you want YO in the form of HF, HR and HO, it is possible. Yes, we can get this, but that much part is sufficient. Let me write it here, or let me clear that it is sufficient. What happened? Sorry. That much part is sufficient. But still, if somebody want to extend this analysis, then he or she can get the value of YO in the form of HF, HO and HR also. Is it? Okay, let us continue and get the value of YO in the form of HF, HO and HR. Now extend, it is just an extension. Let me write, it is an extension. Now observe the equation. YO is equals to what? It is HF multiplied by I1 divided by V2 plus HO. Now this I1 divided by V2, that part, is it? See, YO can be evaluated, can be calculated only when if Vs is equals to 0. This is known at the initial stage of deriving YO. I have declared that Vs must be 0. Then only it is possible to calculate output impedance or output admittance. Is it? Now let us find out this first. I1 divided by V2. Is it? Now if, let me write, if V2, sorry, if Vs is 0, that is Vs is equals to 0, then from input side, look at this, if Vs is equals to 0, then from input side I can write Rs multiply by I1 plus Hi multiply by I1 plus HR multiply by V2 all is equals to 0. Is it? This is what from input side. Input side means I am talking about this. I have this as an input voltage, that is Vs, then here it is Rs, there it is Hi, there it is HR V2. Look at this, I am input side only. This is Hie and this is Rs, and the current flowing through Rs and Hie is I1. So see, this Rs multiply by I1, this voltage, plus this voltage, plus this voltage, all is equals to 0, because this part I am keeping as a null or 0. So I am writing Rs multiply by I1, this is equals to, sorry, this plus this is equals to 0. Then what is common here? I1, I can write Rs plus H equals to minus HR multiply by V2. Obviously this side will go at the right side and it will become negative. Is it? Now what else I can do? Let me scroll the page, and now I am interested in I1, this V2 will come here, then the equation will become minus of HR divided by Rs plus Hi. Is it? So this is V1 divided by, sorry, I1 divided by V2. Now I will put this, what happens, shit, I'll put this value here. I will put this value V1 divided, sorry, I1 divided by V2 in this equation of YO. Sorry. Now here, let me write here, put this value of I1 divided by V2 in equation of YO. Yes, the running handwriting is too bad, I know that. Okay, we have used green pen, no matter, YO. So in the equation of YO, if I put value of I1 divided by V2, then the equation will become, let me rewrite the equation, YO equation will become minus of HF HR divided by Rs plus Hi plus HO. What happened? A plus HO. That's what it is. Right? Or if I rewrite this equation, YO is equals to HR divided by Rs plus Hi. Look at this. This is what YO in the form of YO in the form of HO, HF, HR and Hi. See, all the 4H parameters, all the 4H numbers are included in the equation of YO. See, I told you, if you want to extend, yes, you will get YO in the form of all H parameters. This is what is it. Now, output resistance or output impedance. If the major task, if someone said that output impedance we supposed to derive, and what we have derived is output admittance. So, output impedance, let me write output impedance. Some people call it as a RO, and we are also treating output impedance as an RO. So what is that RO? Then RO is equals to 1 divided by 1 divided by YO. That's what, and this is what your fourth parameter, that is output impedance. Is it? Now see, we have derived 4 parameters of amplifier with reference to the hybrid model of transistor. ये जो 4 parameters है, those parameters, that is input impedance, output impedance, current gain, voltage gain, ये किसके parameter है? Those parameters belongs to the amplifier, but we have derived those amplifier parameters with reference to the transistorized H module. That's what it is. Is it? Now as those parameters that I'm using for amplifier design, those are exact H module, exact derive किया हमने, जो भी हमें दिखता है, whatever we see in the actual hybrid equivalent module, we have used those and we have derived all 4 parameters. But in practical, those parameters are not useful. Is it? At practical life, those hybrid parameters are not useful. Practically, we have to think with a different way. हमें कुछ अलग तरीके से सोचना चाहिए if I want to use those parameters in practical. Is it? See, everything, if I observe this equation YO, it includes HO, HF, HR, HI. Is it? Then third parameter, if I'm using voltage gain, where is voltage gain? The basic equation, yes. If I'm using voltage gain is dependent on current gain, RL and RI. But the current gain itself, see, RI equation is there in the voltage gain. And what is RI? RI is again depend on HI and HR. It means again voltage gain is depend on H parameters. Is it? And if I calculate AI, then again AI is also depend on 2 currents. It means all those amplifier parameters, if I treat them with hybrid H model, then those are depend on hybrid parameters. So सब कुछ hybrid parameters पे ही depend है. If I am using transistor hybrid module, is it? And वही हमें amplifier में use करना है. That's what. Is it? So in next lecture, I will discuss the actual or the practical thing that we need to consider if I want to use hybrid parameters for practical amplifier design. Is it? So in next lecture, we will find out a way where I can use the practical values. Okay. Thank you.